Implementing mediator design pattern. What is that? Actually, this is, in my opinion, the most important design pattern for anything that has UI components. When a UI component needs to talk to a UI component B, you need to arrange somehow this communication. Of course, you can say the wrong way. You can say component A creates a new instance of component B, and this is how they talk. This is tightly coupled components. Component A shouldn't know about component B. They should be encapsulated and reusable. If they don't know about each other, I can use them in different applications in different screens. But if component A expects component B to be there, it's really bad. If in the other example, if in the other application I just need component B or component A, they're like hooked together. It's bad. We don't want to design the components like this. We want them to be loosely coupled. They shouldn't know about each other. So the mediator design pattern, the mediator is acting as a man in the middle. Component A will never directly talk to component B. Component A will give a piece of data to a mediator, and the mediator will give a piece of data to another component. If we decide to create another application that also uses one or both of these components, we'll create another mediator, maybe another parent, and that mediator will be doing something else with a piece of data given by component A. The point is, we need a mediator. Think of a kid playing with Lego blocks. Today he built a car of the same parts. Tomorrow he is building a ship or whatever. A kid, in this case, is a mediator. He knows what to do with these components. But Legos are reusable components in different scenarios. How to arrange a mediator? How to implement a mediator design pattern? I'll show you today an example when the mediator's role is played by the parent component. Parent will have two kids, and parent will serve as a mediator for these siblings. Imagine a brother and sister, and they had arguments and they don't want to talk to each other. They only talk through the parent. A mediator, a man in the middle. This is not the only way to implement a mediator. You could have used dependency injection or a more generic pattern called inversion of control. We could have created a service, an independent service that would be injected into component A and into component B. Component A could put something in this service, and component B could get something from that service. In that case, we wouldn't even have a parent component, but we need something in common. We need a man in the middle. This could, in our case that we will be doing today, we are using parent component as a mediator. But you could have used any standalone service injected in both of them, something that know about each. Inversion of control design pattern means that I am not be creating what I need, but I'll be given what I need. The control inverts. Not I am in the driver's seat, but they will give me something. Let's go back to this picture I showed you earlier. And now it's a very difficult quiz. How the number 7 can send the data to the number 6. How this guy can pass some data to the number 6. Any idea? Use your imagination. Broadcast to whom? Again, I told you something about mediator now, right? So how this applicable in this quiz? Metro says 7 to 3. Exactly. 7 will emit an event. To whom? To its parent. Who is the parent? Number 3. 3 will re-emit this event to its parent. Who is its parent? Number 1. And number 1 will send it over to number 6. See this? Metro is the leader. It's not through bubbling, guys. It's through dispatching events. Number 7 and number 8, they have a mediator number 3. Through this number 3, they can talk to each other, 7 and 8. But this is not what I asked you in the quiz. I want to establish, see, all of these guys are loosely coupled. They don't know about anything around them. So, but we are building an application. We are assembling these Legos in one screen. So number 7 will emit an event. If this is a parent container, I would need to create a listener that would be listening to this number 7's event. In the event handler of number 3, I will in turn emit event to my parent. My parent is number 1 of number 3, right? The parent will have a listener. The parent will understand that I got an event from number 3, and if the event is so and so, I need to pass it to number 6. You got it? I can give even more difficult quiz. How number 8 can pass something to number 5. Same idea. 8 is emitting an event. 8 has no idea about number 5. Number 3 will get it, re-emit it to number 1. Number 1 re-emitted to number 1 will use binding in properties. Over here we'll have an input property to number 2. Number 2 will be using binding to its child number 5. So 8 to 1 through 8 to 3 through an event output property, 3 to 1 through an event output property, 1 to 2 through the input property using binding, 2 to 5 through the input property using binding. Is it too difficult? Shouldn't be. I usually explain things well. Now let's implement it, guys. Otherwise you wouldn't be trusting me that whatever I say is true. Now we will create a little application that illustrates this. Remember the price quarter component? What it knows how to do. It knows how to connect to stock exchange, get the prices, and emit them. To whom? I don't know. The price quarter component, don't know. My goal is to emit the new price as soon as I get it, or every 1,000 milliseconds. So price quarter component through the output property will emit an event. In the application component, who is a parent of this guy, we will create a listener. And as soon as we get this price quote for a certain stock, using binding, we'll pass it over through the input property of order component. Does order component know about price quarter component? No. These guys are loosely coupled. Imagine the situation. I created this beautiful application and it works. There is a button buy, for example. There is a button buy on the price quarter component here. I am a trader. I'm sitting all day long and watching at the prices of IBM. As soon as I like the price quote, click, I push the button buy over here. I push the button buy, it emits an event, app component will pass it over, this command, buy me at the price $75, 100 shares, to this guy. This guy knows how to place an order for stock purchase. So this guy knows his thing, how to place an order. This guy knows his thing, how to show the price quote. If tomorrow my manager comes to me and say, Jakob, I like your price quarter component, but I just want to display prices. I'm not going to be placing orders. Can I reuse it? Sure. Just take this price quarter component and put it on some dashboard application. Price quoter component is not linked in any way with all placing orders. And this is exactly what you will be doing now in walkthrough number 8. What I want you to do is run this. I prepared this application for you. It is sitting in the folder app mediator mediator. And it should work like charm. It's right here. Actually, before you start working on it, just let me tell you a couple of things that are important here. I want to explain you one important thing. Stock TS. I created an interface, stock, which consists of stock symbol and bid price. The price quoter component will be emitting objects of type stock. See, stock to buy. Stock to buy is what? Of type stock. Stock is an interface declared over here in a separate file. The word separate is very important in my explanation. Remember, it's sitting in a separate file. Now, if you will be compiling this code using TypeScript, what do we get as an output? For other code is fine. TypeScript will find an equivalent in JavaScript and produce a JavaScript for you. But there is no equivalent in JavaScript for interfaces. JavaScript doesn't support interfaces. So what TypeScript will do? TypeScript will generate an empty JavaScript file for this, because there is no equivalent in JavaScript for interfaces. And this is exactly what I tried for the very first time, and I ran into an error. System loader started to loading my code and started to give me an error with this type. I looked at the generated code that actually runs on the browser, and I see that this piece is empty. And System.js doesn't know that it's supposed to treat an empty file as a meaningful module. So then in the documentation we found that system loader allows you to use so-called meta annotation. Please pay attention, otherwise your interfaces declared in separate files won't work. This meta annotation, you can declare, dear system loader, I have this guy called stock TS. Please treat it as a module. Then it stopped complaining and the code started to work. In the previous example, with output bindings, I defined the interface right inside. So there were no problem. The System.js didn't see that there is some weird file with no content. It was not complaining because this was sitting as a part of the entire code. Yes, there was no equivalent for this in JavaScript, so it was just removed, but at least the rest of the code was there. But in this example, since we placed it in a separate code, in separate file, which is needed in both price quoter, we use this type somewhere over here, see type stock. And in the order, we use it, right? From the JavaScript perspective, it could care less what it's sitting here. It understands that it receives an object. But without that meta annotation, we had a situation when we asked system loader to load an empty file, and it didn't like it. So now please go ahead and do this walkthrough number 8. What do you say, Eugene? Same as Angular 1. What do you mean by this? See? stock order is generating prices. I don't do anything. See my hands? They are here. Whenever I click on the button buy, this pink component will emit an event. The mediator will catch it and using binding will give it to this cyan component. Let me click on the buy. See this? I'm buying. Let me click again. I'm buying. So two components talk to each other without knowing about each other. Isn't it great?